Hey everybody, let's take a look at this section of a table that we're trying to complete where we are given three columns of information. One is the molar mass of a substance, and in this particular example that has been provided to us, 322.2 grams per mole. That 322.2 comes from these exact amounts of each atom, and some of that I know: 2 sodiums, 1 sulfur, 4 oxygens, and some unknown quantity of water molecules. And all of that connects back to the formula of the substance, which of course we know there's 2 sodiums, 1 sulfur, 4 oxygens. Again, we just don't know the number of water molecules. Let's walk through how to figure this out. So let's take advantage of some of the information that we do have, like the quantity of sodium atoms is 2. If you find the molar mass of sodium as 23 and multiply it by 2, we can start adding up all of the molar masses that at least we do know. So 23 times 2 for the sodiums, plus sulfur's molar mass is 32, and there's just one of those because there's 1 sulfur. Oxygen's molar mass is 16, and I'm rounding these because they're essentially 15.99. For oxygen is essentially 16. But 16 times 4 for those 4 oxygens. And there's this mystery piece, right? This part of it that I don't know, which is the water molecules. But I do know that all of these numbers, all these molar masses, have to add up to the total of 322.2 grams per mole. And if I know that they all have to add up to that amount, then I can essentially treat this question mark almost like it was an x value in a very simple algebraic expression and solve for that x. And if you do that, you'll find that your x value is 180.2. So that means whatever this mystery quantity of water molecules is, it has to add up to 180.2 in order for this whole expression to make sense. So now we have another challenge though. How many water molecules would do that? Just looking at it, I have no idea. You probably don't either. Let's start trying things though. Let's try 1 water molecule and see if that would add up to 180.2 in terms of molar mass. If you go to the periodic table and find hydrogen as 1 times 2, because there's 2 of them, add that to oxygen's 16, you'll see that a water molecule is 18 grams per mole. And you should notice something about these two numbers right off the bat, 18 and then 180. If you don't notice it, let's just kind of keep working through this. The point is, 1 water molecule only equals 18 grams per mole, and that's not enough, right? 1 water molecule is not my answer because it's not going to account for all 180. So then you can kind of just start trying things. If you don't see how this is going to work, what about 2 water molecules? If it was 2 water molecules, then that's going to be twice as much. 18 times 2, that's going to be 36 grams per mole. That's not it either. I guess we should start crossing out the ones that don't work. That's not going to work either because it's not 180. And you can keep doing this until you land on a certain number of water molecules that actually adds up to 180. Most of you can probably see at this point what that number of water molecules is going to be, and that is 10. Finally, at 10 water molecules, 10 times that 18 is going to be the 180 grams per mole we were trying to account for. You might have noticed it was going to be 10 right from the beginning by imagining, these numbers are pretty easy to see that with. 18 times 10 gives you the 180 we were trying to achieve, or you could just keep trying different amounts until you ended up with 180. Either way, I now know that the only way for all of this to add up to 322 is for there to be 10 water molecules as part of this formula. Now I go back to the first column that was asking me to say, how many water molecules that was in the formula of the substance itself, and I can simply fill out 10.